Inequalities are solved the same way we solve equations, for the most part. Look at these four examples, and just pretend we had equal signs on each one. This one has an equal, so I'm going to change that to a less than equal to. Look at the first equation. X plus 3 is less than negative 10. What would you do to solve that if it said x plus 3 equals negative 10? I hope you said subtract 3 from both sides. That will isolate your variable x and give you negative 13 on the other side. But instead of an equals, we have an inequality sign. That means any number that's less than negative 13 would make this statement true. Look at the second equation. What do you do to solve this equation? 5 plus x on one side, 8 on the other. Subtract 5 from both sides. That leaves x by itself, just like with equations. 8 minus 5 is 3. But instead of an equation, we have an inequality statement. Any number greater than 3 makes that statement true. All right, next inequality. X minus 12. Well, to get x by itself, you do the inverse of subtracting 12. Remember that the inverse of subtracting 12 is adding 12. That leaves x by itself, less than equal to in the middle, negative 6. Any number that's less than negative 6 makes that statement true. Finally, we have an inequality statement where it's a one step, but this time the one step is to divide by the coefficient. X is less than or equal to negative 3. All of those inequalities I solved exactly the same way I would have solved if there had been equal signs in the middle instead of a less than or a greater than. There's only one new rule to remember. When you multiply or divide by a negative number, reverse your inequality sign. That means a greater than sign will turn into a less than sign, like it will in this example. The coefficient here is negative 5, so I'm going to divide both sides by negative 5. And when I do that, now I'm going to still have x on the right because the negative 5's canceled. Excuse me, that's on the left. But I'll flip this sign around, and the greater than equal to becomes a less than equal to. 25 divided by negative 5 is still negative 5. All the rules for integers are still true. Positive divided by negative will still be negative. So the second equation, the coefficient is negative 3. I'm going to divide by that coefficient. It's a one-step inequality, but I do have to remember the new rule. Flip the inequality sign. Negative divided by negative, the signs are the same, so I get a positive answer, just like I would if I had an equation. All right, if your variable is on the right side of the equals like it is over here, that's fine. You still divide by the coefficient, negative 4. That gives me a negative 3 on the left, greater than x. It doesn't matter what your constant is on the other side. If it's positive or negative, you still follow the same rules for positive and negative numbers. So I will divide by negative 10 in the last equation because that's the coefficient. Every time you find yourself multiplying or dividing by a negative number, flip that inequality sign around. All the other rules stay the same. So look at these 6 examples. We'll look at these one by one and decide, are we going to reverse or not. The equation 3x is greater than negative 15. What's the coefficient there that I need to divide by? It's a positive 3, so I do not flip the inequality sign around. I just divide. All the rules for signs are still the same. Negative divided by positive is negative, and that's why I have a negative answer. I did not flip the inequality because I divided by a positive number. What about this equation? Well, to solve this equation, you have to subtract 2. This means 2 plus x. The inverse of adding 2 is subtracting 2. Same thing on both sides. I do not flip the inequality. I just subtract 2 from 7, and that gives me a 5 on the right. Just like solving equations, once x is by itself with a coefficient of positive 1, you're finished. Next equation. Think about what you would do to solve this equation right here. All right, I hope you said divide by negative 5 on both sides. Divide by negative 5. Now that means I still use the same rules for integers here. Negative 15 divided by negative 5 is positive 3. The inequality sign has to be flipped because I divided by negative 5. And that leaves x by itself on the right because negative 5 divided by negative 5 is positive 1. I'll go a little faster now. Next equation, negative 8x is greater than 64. Divide by the coefficient. Since the coefficient is a negative number, flip the inequality sign around. Whether your coefficient, your variable, are on the right or the left, you have to look for your variable. Look what's next to it, negative 10. So I'll divide by negative 10. Gives me positive 10 is greater than or equal to x. What about the last equation on this slide? Do I multiply or divide by anything? No. Negative 6 plus x. I want to get rid of this negative 6. The inverse is to add 6 to both sides. That leaves x by itself on the left with a coefficient of positive 1. I do not flip the inequality because I did not multiply or divide by a negative number. Negative 6 plus 6 adds up to 0. That means any number greater than 0 will make that statement true. In other words, any positive number. All right, here are a few more. Now, I noticed solving equations that some of you are still confused when you see a variable over a constant, like this one. This means n divided by negative 3. It's not telling you to divide. It's saying what number that you would divide by negative 3 would give you 5 on the other side. Well, the inverse of dividing by negative 3 is to multiply by negative 3. That leaves n over here, because the n on the top cancels out with the 3 on the top cancels out with the n on the bottom. Since I multiplied by a negative 3, flip the inequality sign, and positive 5 times negative 3 is negative 15. All right, over here, this means x divided by 6. The inverse is to multiply by 6. If you multiply on the left, you have to multiply on the right. That cancels out these 6's, leaves x by itself with a coefficient of positive 1. Since I multiplied by a positive number, I will not flip the inequality sign. That would make it wrong. What am I going to multiply by here? Well, I hope you said 5, because that's the only thing that will cancel out on the right to leave the variable by itself. the positive 5, do not reverse the inequality sign. Over here, multiply by 7 on both sides. Take a close, careful look at these 4 inequalities because I saw this came up with a lot of questions when we did these with equations. And remember, you have to use all the rules we use for equations to solve inequalities, plus 1 new rule. All right, when we get to 2-step equations, all the steps are going to be very similar to the steps for 2-step equations. Just pretend that this is an equal sign here if you want to. Just for now, I'll just do that. All right, so what would I do first? Subtract 7 on both sides. That would give me 5 minus 7 is negative 2. Now I do want to bring back that inequality sign so I don't forget about it. Last step is divide by the coefficient, positive 2. Since it's positive, do not flip the inequality sign. All right, I'm going to do this one next. Negative 5 plus x is less than 20. Look carefully. The inverse of negative 5 is positive 5, so I'm adding 5 to both sides. That leaves x by itself with a coefficient of positive 1, 25 on the other side. Think about this one just for a moment. I see a subtraction problem, but the inverse is not going to be add 6. The 6 at the front of the equation is positive. You need to subtract 6. Think about it now. If you added another 6, you would get 12 minus 2x, and you haven't isolated the variable term. But taking 6 away makes these two add up to 0. When that happens, you're not left with 2x is greater than or equal to 12. You're left with negative 2x. If there's a minus sign in front of the 2x, start calling it negative 2x after the 6 is gone. Divide by the coefficient, which is negative 2. And since it's a negative 2, guess what? Flip the inequality sign. Positive 12 divided by negative 2 will be negative 6. The sign on your answer is whatever it would be if you had an equation there. But the inequality in between gets flipped. And this last equation here, I can get y'all with this every time. Negative 8 minus x. I want x by itself. Add 8 to both sides. That leaves me with negative x. Ask yourself, are you remembering that? And look at your old test and see if you missed any of the equations where you were supposed to have a negative there. All right, that means now the coefficient I have is negative 1. Then divide by negative 1. That changes the sign from negative x to positive x. I want it to. Flip the inequality. Negative divided by negative will be positive. So what I hope you remember is that when you have multi-step inequalities to solve, you'll do everything we just did. Those were examples of mostly one-step inequalities. You can have parentheses, like terms on the same side, and like terms on opposite sides. And you'll use all the same rules that you use to solve equations. And you have to remember, reverse the inequality sign when? When you multiply or divide by a negative number. Take your time reviewing these equations that you just worked through. Make sure you understand how to solve them and bring in any questions you have when you come into class tomorrow.